So before we take a look at example 2, let's quickly review the acronym BOBO, BOTN, EATS, DC for finding the horizontal asymptote of a rational function. So if we have some examples of rational functions to consider, for example, 3x plus 2 divided by 2x minus 3. Let's try 3x squared divided by 2x minus 3, and then 3x plus 2 divided by x squared. So BOBO stands for bigger on bottom 0 when the degree of the denominator is bigger than the degree of the numerator. The horizontal asymptote, which would be the limit as x approaches infinity, is equal to 0. So this would be an example where the degree of the numerator is bigger, or sorry, the degree of the denominator is bigger than the degree of the numerator. The horizontal asymptote would be y equals 0. Okay, then BOTN, bigger on top none. If the degree of the numerator is bigger than the degree of the denominator, like in this example, 3x squared over 2x minus 3, then there is no limit. As x approaches infinity, the limit does not exist. And that would be this example. So does not exist would be our horizontal asymptote and the limit. Then EATS DC means exponents are the same, divide the coefficients. So in this example, 3x plus 2 divided by the quantity 2x minus 3, both of the numerator and denominator are linear, so the exponents are the same, and we would divide the leading coefficients. 3 divided by 2, that would be the horizontal asymptote, which is the limit as x approaches infinity, either to the left or the right. So let's take a look at example 2. We're going to use that acronym BOBO, BOTN, EATS, DC to evaluate each limit. So in A, 2 divided by the quantity x plus 3, the degree of the numerator is 0, the degree of the denominator is 1, so the bigger on bottom 0 means that our limit as x approaches positive infinity or negative infinity is 0. In B, 7x divided by negative 4x plus 1, the degree is the same. Both of the numerator and the denominator are linear, so that's EATS DC. Exponents are the same, divide coefficients to evaluate the limit. So when we divide 7 by negative 4, that gives us a horizontal asymptote of negative 7/4, which would be the limit as x approaches infinity. In C, 3x plus 1 divided by 5x minus 4, again, the degree is the same on the top and the bottom, so the ratio of the coefficients, 3/5, would be the limit as x approaches infinity. That's our horizontal asymptote. X plus 1 divided by x squared minus 3. This is bigger on bottom, and BOTN bigger on top is none. BOBO bigger on bottom 0. So bigger on bottom means that our limit as x approaches negative infinity is 0. Then E, the limit as x approaches infinity of 6x squared plus x divided by 2x minus 5. This is bigger on top, so the limit does not exist. BOTN is bigger on top, none. And then F, limit as x approaches infinity of 4x squared over x squared plus 10,000x. The degree is the same, and that's EATS DC. Exponents are the same, divide coefficients. And 4 divided by 1 means that as x approaches infinity, we're approaching 4.